5.1 Learning Objectives A and B, I'm going to show you how to graph a quadratic function using a table and then by finding the vertex and axis of symmetry. First, let's start with some vocabulary. We're going to define these first four terms. A quadratic function would look something of this format: y equals ax squared plus bx plus c. Now, if I put numbers in it, you might see something like y equals, let's say, 2x squared plus 3x plus 1. Now, if you graph this on graph paper, where you have an xy axis, what's going to happen is you're going to get a shape that looks something like this. The shape that a quadratic function makes when you graph it is called a parabola. Okay? Every parabola has a vertex and axis of symmetry. The vertex in this particular picture would be about right here. And the definition is it's the turning point of the parabola. So if you look at this as they sketch the parabola, you know, here they're going down, down, down. At this point, you start turning and you start moving upward. So that's why it's called the turning point. Now, through the turning point is an imaginary line that's kind of like a mirror. If I were to come into here through this axis of symmetry, or the vertex, and draw this imaginary vertical line, what that is called is the axis of symmetry. And what it is, it's a vertical line the parabola reflects over. So again, we have this axis of symmetry, which is going through the vertex. And what we see is if we look at the right-hand side of this parabola, its mirror image, if you flip it over this black line, would be the left-hand side of the parabola. And that's why we call that black line the axis of symmetry. It's where the graph would flip and have its image. So what we're going to do today is we're going to graph a parabola, we're going to use some ordered pairs, and we're also going to find the vertex and axis of symmetry. If you like having steps, here's the first thing they suggest to do. First one is to draw the axis of symmetry. And you actually have to find it. It is the line that goes through the x equals, the line is negative b over 2a. So what you have to do is you look at the equation, you find the number that sits where b is, you find the number where a sits, and you plug it into this equation, and you would get a vertical line with some numbers, and you plot that. Okay, after you do that, find and plot the vertex. The x-coordinate of the vertex is the axis of symmetry, or it's that negative b over 2a. We already found it right above there. Once you know the x value, you substitute this for x into your function. So you go back up in here and you put it in for x, and then you evaluate it and find the y value. Okay. So then once you've done that, you're going to plot your vertex. So if you think about it, let's say here's our graph paper. Let's say we found the axis of symmetry and it was right here. And then we found the vertex and we realized it was this point sitting on there. And by the way, the parabola is going to make a U shape that reflects over that red line. So step 3 says, now they want you to plot 2 points on one side of the axis of symmetry. And once you have that, use the property of symmetry to plot 2 more points on the other side. So really all we have to do, we're going to have to make a table of values and find 2 points, something over on this side. Let's say we did it and we found that the points were here and here. Okay, well, step 3 says, fine, take this 1 point and reflect it over here, take this and reflect it over here. Whammo, we got it. So draw the parabola through the points and you're done. So let's look at 2 examples. Okay, here is our quadratic function. By the way, let's just recall for a second a, b, and c. A is always with the x squared, so it's the coefficient there, it's 3. B is always with the x, which is 6. C is the constant, or the number by itself, which is negative 1. Okay, I like to write those down on the side. Now, step 1 says, let's find that axis of symmetry. Well, the formula for axis of symmetry was x equals negative b over 2a. By the way, this is an equation of a vertical line. So I have to use this little part to figure out what number the vertical line is going to go through. So I'm going to come in here. B is 6, so I do negative 6 over 2 times a was 3. Okay, so negative 6 over 6 is negative 1. So if I ask you for the axis of symmetry, it is the equation x equals negative 1. You would have to type it in as an equation. Okay, let's go sketch it. Well, negative 1 is right here, and it's going to go right down there. So I know my parabola is going to reflect over that line. Now, where on that blue line is that little vertex going to sit? Where's the turning point going to be? Okay, next step is find that turning point. So that says we'll use the x that we found here. Okay, so the turning point, or the vertex, is going to happen at, I already have half the answer, negative 1. Well, the question is, what's this y value? All you have to do is you take x of negative 1 and you put it back into the equation and you see. Okay, so y equals, I'm going to do 3 negative 1 squared plus 6 times negative 1 minus 1. Do not forget your PEMDAS. Do parentheses first or the exponents, so negative 1 squared is 1. I'll do 6 times negative 1 is negative 6 minus 1. So I have 3 minus 6 minus 1. 3 minus 6 is negative 3, and then minus 1. So we have negative 4. So the vertex sits at negative 1, negative 4. So I'm going to sketch that vertex, negative 1, and then 1, 2, 3, 4, right there. Okay, last step says, okay, pick 2 points on one side, and I'm going to choose this side, and I get to pick what I want. It doesn't matter. So I'm going to go here and make my table of values. I'll just do x and y. Why don't I try what if x was 0 and what if it was 1? So I'm just going to do 0 and 1. So I'm going to choose 0 and 1, and I'm just going to put that into this equation up here. So 3 times 0 squared plus 6 times 0 minus 1. Well, that's 0 and 0, so it's 0 minus 1, negative 1. Okay. So by the way, I'm going to plot 0, negative 1 is right here. Okay. Next one, let's try 1. So 3 times 1 squared plus 6 times 1 minus 1. Do 1 squared first. 1 times 1 is 1. Then times 3, it's 3. 6 times 1 is 6, minus 1. This is actually going to give me, it looks like, 8. Okay, so I'm going to plot the ordered pair. That goes 8. 1, 8. Looks like I might actually go off my graph paper on this, so I have to go up, or 1, 2, 3, 4, 5, 6, 7, 8. So 1, 8 is going to be from the origin right 1, up 8. Right up here. Okay, now these are going to reflect over the blue line. So I'm going to take this first black point, and it's 1 space from the blue, so over here it's 1 space. This next one, maybe I'll bring my axis of symmetry up a bit. This black line is 2 spaces from the blue point, so the next one is 2 spaces from the blue point at the same level. So then I just connect the dots and make this parabola, which is my U shape. If I labeled this, by the way, I would say this is my vertex, which happened at the ordered pair again, negative 1, negative 4. This blue line is the axis of symmetry. Just going to abbreviate, which was the equation x equals negative 1. Okay, let's look at graphing another parabola. So here they do want us to sketch it, label the vertex and axis of symmetry. So step 1 is to find that axis of symmetry. Remember, it's the equation x equals negative b over 2a. Again, I like to identify A, B, and C from my equation. A is 2, B is the 4, C is negative 3. So I'm going to do negative, and then B is 4. 2 is the 2 for this formula, and the A value is 2. So here again, it actually is negative 1. And this isn't always the case, you guys. It just happens to be this example has the same axis of symmetry. So I go to x of negative 1, vertical line, and I'm going to write x equals negative 1. Then I'll put this as the axis of symmetry. So let's find the vertex. Remember, the vertex happens at, it's negative b over 2a is the x value. Then we have to go find the y value. Well, we have the x value. It's right here. We already found it, which is nice. I like it because it's halfway done already. To find the y value, I'm going to put our x value of negative 1 back into this equation and see what we get. So for this, we'll do y equals 2 times negative 1 squared plus 4 times negative 1 minus 3. Negative 1 squared is 1 times 2 is 2. 4 times negative 1 is negative 4, so it changes the subtraction, minus 3. Be careful, 2 minus 4 is negative 2. Negative 2 minus 3 is negative 5. So the vertex happens at negative 1, negative 5. So I'm going to plot that, negative 1, negative 5. And I'm going to label it, I'll put negative 1, negative 5, and I'm going to call it the vertex. Let's finish off the problem by finding 2 points. And why don't we just choose, again, 0 and 1 looks good for this case. If I put 0 in for x, I'm going to get 2 times 0 squared plus 4 times 0 minus 3. That'll be negative 3. So 0, negative 3 is 1 point. You know what I'm going to do? It's mirrored reflection right now. It's right over here. Okay. Next one, if I put 1 in, 2 times 1 squared plus 4 times 1 minus 3. 1 squared is 1, times 2 is 2, and then 4 times 1 is 4 minus 3. So 6 minus 3 is 3. So at the order pair 1, 3 is another point. It's going to be 2 spaces from the blue line on the other side. Connect the dots. Whammo, we have our parabola.